Okay, we are going to go and see about putting in some FITS data. So if you know anything about astronomy, you clearly know. No, that's not a thing. Okay, so in astronomy, whenever they pull data and they look at, whatever, basically they take a camera and they use a red filter on it and they take a picture, and then they take a green filter and then take a picture, and then put on a blue filter, put a picture on it, except they do it in more complicated sciencey ways. But what's really cool is all the data that ever comes out of NASA is publicly available because it's your tax dollars that pay for it, so we get access to all the data. So there's this website that's pretty good, and I'll link it in the comments or in the description, is MATLAB. And so MATLAB has all these example data sets, and they have all these other things you can do with the FITS data, but apparently it's being weird. So it keeps trying to, there we go. Okay, so I think that maybe the probably most famous one that you might have seen is the Eagle Nebula. It's also called the Pillars of Creation. So if I just Google Pillars of Creation, you get this thing. So if you've seen this image or older versions of it, so that's with the old telescope, this is the new telescope, that kind of thing. Okay, so I'm going to go, and there's this information here. So these tell you which filters, so like the red, green, and blue, for example, there. And this is the data that I actually want to plot, and it's something I can do in MATLAB, which is pretty cool. So I'm going to download the zip file, which should have everything in it. Then I'm going to put it here and extract. All right, so here is my NMOS, my 502 NMOS, my 656 NMOS, and 673 NMOS. With I sound, I just say that very, very fancily, but really what that just means is these are the nanometer filters. So nanometer filter. Okay, so I'm going to now unzip these. Unzip, unzip, and unzip. These are enormous files, by the way. There is so much information in there. It's not just like the pretty picture file. It's kind of crazy. Okay, so what I'm going to do is I'm going to take all of these and I'm going to put them back in my base folder so that I can access all of them. So cut, paste, and then cut and paste. Okay, so now I can get rid of this, and the only things that I really need, I've just got these extra things in here for no reason. I can delete them. Oops. Okay, so I've got these 3 files here, and they're beautiful, and I love them. I want to do things with them. Now, I had another video where I went into this crazy long discussion of how you can import, and then you can adjust, and blah, 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 blah. And then I had a student who was just like, but you could just do it this way. And I was like, oh my gosh, everyone's a genius but me. So I'm going to create a new, not a live script, a new regular script. And it's actually way more straightforward than I had made it in the past. It's actually super fun. So I'm just going to start with the CLC clear. I'm just going to call this my FITS data. Okay, and it doesn't really matter what you call it, but I just might call it red, and I'm going to do FITS read. That's all. I had done all this other crazy stuff, and I didn't need to. I don't really know if it matters which one you call red, blue, and green. You can probably change those around and just kind of see what those answers look like. Green, FITS read, and 673 MOS, nanometer OS FITS. Okay, I definitely don't want to see that data. If you run it, you'll see it's a 1600 by a 1600 double. Okay, so basically, if you think about how a picture works, a picture in RGB works in red, greens, and blues. And so what we're basically going to do is we're going to control the intensity at which these red, green, and blue numbers show up. So if I just open this here, I can see a lot of zeros and maybe nothing as it sits and it tries really hard to catch up. There we go. Oh, and then there's up to 9s. Okay, let's see what the max is. What's the max of blue? Oh, what's the max of blue? A really, 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 really big number. Okay. So I think what I want to do is I'm going to scale some of these numbers down, but let's first of all think about how we're going to plot this. So basically we're going to make a new image, and instead of making a 16 by 1600 matrix, so imagine you have each one of those 1600 by 1600 matrices, and you want to make a cube out of them. Instead of just having like 3 flat pieces of paper, you want to line them up and staple them in the left-hand corner. Okay, so basically what we're going to say is we're going to create something called a 3D matrix, which is something I haven't really talked about before, but it's super cool. It's just basically a 2D matrix, but with a third dimension. So I can say I want all rows, all columns, the first, call it page, to be equal to the red colors. New image, plump, plump. Second page, I want to be the blue colors, and new image, plump, plump. 3, I want to be the green colors. Okay, so basically this is a 1600 by 1600 by 3 matrix, which is how a lot of computers store visual data. And there's this thing called IM_show, which is basically another version of plot. It's just that you're showing it as an image. So if I plot new image, let's see what it actually does. I can't remember. Oh, okay, it can't do it. Can I do it in plot 3? No, not enough input arguments. Okay, then never mind. So it's not going to work. So I'm going to use something called IM_show, new image, and it pops up with a picture that I can't really tell what's going on. So let's undock it and look and see a little bit more carefully. Okay, there's clearly data here. It's just super duper washed out, which probably means that all my numbers are too big, so I need to chill them out a little bit. Okay, so I'm going to do something weird. I'm just going to randomly start picking numbers, and there's probably ways to do this, and people who are really into science or whatever are like, oh my gosh, I can't believe you did that. That's such a dumb way to do it. But that's okay. I learn things by doing things the dumb way, and then eventually I figure out the smarter way. It just might take a really long time. So if I just divide everything, you're taking away the intensity, and you can see that pillars of creation, things start to pop up. That's pretty cool, right? Pretty cool, pretty cool. It's also sideways. Can I like transpose this? No, I don't want to transpose the 150. I'll transpose that. There, now it's straight up and down. I mean, not that there's a straight up and down in the universe, but you know what I mean. It makes me feel better. So essentially what I can do now is I can change these values, and it'll change the saturation of, my picture. So if I want a really purple picture, there we go. If I want a other kind of picture, I have no idea what I'm doing. I'm just changing these numbers and seeing what happens. Whoa. If I want it super red, can I just divide by 1? There, now it got redder. Now I want more blue. Oh, that was too much blue. Just slightly more blue. Just made it brighter. I don't know what I'm doing. Green. Green. It's not really doing anything. There. Oh, that is okay. I'm not very good at observing. It's clearly doing things, and I'm just a little slow. Oh, interesting. That didn't seem to help. Anyway, so that's really all I wanted to do here, is just show you that you can do this. You can pull in cool. Oh, it might be because it was so red, nothing else was doing anything. Oh, now we're back to green again. That green really does need to chill out. Anyway, so maybe this is something you can mess around with, have fun with, play with, and eventually play around and get a pretty picture. And also, just because I'm a big dork, I may or may not have spent like 10 minutes just playing around with the different colors, and I just wanted to show you which ones I liked, because it's pink and purple and it's pretty. So just whenever you see pictures of the universe and people say, well, they're in false color. I mean, they're in false color in that we're showing spectrums that we can't see with our regular eyes, but if we were birds, maybe we could see it. So anyway, these are my numbers that I divided by, and I got a pretty picture. So you should try some of the other data sets and see what you can come up with.